All right. So every training session starts with a safety briefing. Okay. Simply because, well, it's important. We are going to be working with hot things. Okay. These irons are fully capable of leaving good permanent marks on your skin. The burns hurt because they are very localized. We are going to be melting metal. If you don't understand what that means, you're probably in the wrong place. Okay. So burns are the number one injury potential here. Cuts are number two. We are working with sharp metal. We are going to be making it sharper by cutting it. And we will get there. Eye protection is actually kind of important. If you have it, wear it, because we're, again, going to be working with sharp metal, cutting things. Bits go flying, and they do so often. Did your kit not come with a stand for your iron?
I can't find it. It's probably in there. I just can't see it.
Well, then we'll have to examine the kits and see what everybody's got going on. Okay. Good ventilation is important. The fluxes especially produce some fumes. Some people worry about lead fumes. Lead doesn't vaporize at the temperatures we're going to worry about, but people still get concerned. And good lighting. It helps to see what you're looking at so you can avoid the other problems. Okay. I don't think long safety briefings are helpful. That's all there is.
How
You have questions.
strict are you being with all the eye protectors? Like I have in my truck.
You know what? If you want to go get your safety glasses, go get your safety glasses. You will probably want them before we get deep involved, just because it's safer that way.
Oh, back.
Okay. I can wait, or we can just move on and come back and cover things without you. Go, run, quick. See, looking at where he's set up, I already know I can skip. He can miss the next part. Critical tools. Soldering iron. This is an old beast of a soldering iron. I bought this iron in 2002 at Radio Shack. Okay. This is an old beast. It still works. It's not a good iron, but it works. Solder. Okay. Stuff like this. Or this. Or this. Okay. All of these melt different temperatures for different reasons. But you have to be able to solder. You have to have solder. Edge cutters like this, or I'm sure some came with kits, or we just got some. The idea is to cut the leads after you solder and make a neat cut. This is where flying bits get involved. Okay. Tip cleaners of some variety. You will note that all of you should have a sponge now. I have a sponge, looks a lot like that. Some folks like to use brass pads. I use them both. Okay. Cleaning with a dirty tip, soldering with a dirty soldering tip is about as useful as bathing in mud. Yeah, you can eventually get there, but it's not a fun job. Okay. Those are what I consider essential tools. Soldering iron, edge cutters, tip cleaners, solder. Okay. Without those, you can't do the job.
What?
Those are not essential. They're optional. Optional tools. A safe place to solder. You all have aluminum trays. Okay. I have both a silicon mat and a ceramic tile. This thing cost me $2 at Home Depot a long time ago. Yeah, I was getting fancy. I actually like the back better because parts don't roll around and fly off. This side, it slides right off. Nice part is so does solder. It cleans real easy. The important part is it's fireproof.
So what is this?
This?
Yeah, tell me again.
This is a ceramic tile from Home Depot.
Just a ceramic tile.
Just a ceramic 8-inch tile. Heck, made in the USA even.
So something that's rough is probably better than something.
Rough surfaces. I actually prefer the back of the tile, but sometimes I solder on the side too. Depends what I'm doing. It's good for visibility at the very least. Silicon solder mat. This thing folds up, rolls up, comes with me. This is actually a new one to replace the old one that has been with me way too long. when it starts splitting in the middle, and yeah, it's time for it to get replaced. So safe place to solder is important. Solder removal tools are also useful. They come in many varieties. Here's the old school bulb. You squeeze it, put it next to the joint, let it go. Solder goes up and inside. It rattles because it's full of lead. Solder wick, totally different material. Totally different use case than the solder sucker, but it works pretty darn good. And of course, the all-powerful vacuum spring-loaded solder sucking tool. This thing will hang on your arm with the vacuum it creates. Yeah, not quite that good, but it's dang close. This one's actually new. I think I paid $14 for it, and it comes with a whole bunch of spare silicon tips. Don't know if you can see those on there. That silicon tip is really good at getting close, and it comes with a bunch of spares. Okay, solder removal tools are great. Covered the wick and the flux, well, flux and pen. Flux pen.
Question, so what's the difference between that little squeegee model and center sense?
These two both do the same job.
Yeah.
This one's more precise, and it actually, well, it sucks more.
So, so you got a bulb or something, that little guy is a good.
Yeah, this guy is a great backup, but I will prefer the spring-loaded beast all the time. Okay, solder flux paste. There's my flux paste. Dip your soldering iron into it. We'll clean it on a little bit. You can use the screwdriver, tweezers, whatever. Yeah, flux paste. I have some right here.
Is that a critical thing? It's not?
You have a flux pen. Yeah, see?
Oh,
Here's his flux. You have a flux pen. Great tools. It's a simple tool. You put it on, you dab, you get a little bit of flux on there. This stuff smells. It's going to generate smoke. All of it is. But this stuff is useful. It makes sure the solder goes where you want. Yes, sir.
Talk about using flux paste versus using solder flux or rosin flux.
Not yet. We're getting there.
Okay, I'll show you.
Okay. So flux pen, tweezers. Everybody has a pair of tweezers. Some people even use them for tweezing things. I have multiple varieties of tweezers. Okay. Angle tips, straight tips, self-clamping. They're all useful. Depends what you're trying to do. As a general rule, the bigger the parts, the bigger the tweezers, until you get to things that aren't really tweezers at all. But they can act like them. And the other half of that is picks. Really sharp, pointy ends. Okay? You'd be amazed, or maybe not, at how many uses these sharp, pointy ends have. This one came from an auto shop. It is not a dental pick. A lot of folks think this is a dental pick. You can use dental tools, but this one has a magnet in the back. Really useful for picking up little tiny screws. Multimeter. Well, I've got lots of multimeters. Come in all kinds of varieties. If I can not drop them on the floor. There's your classic right there. This guy measures all the basics. It's a classic for a reason. It does all the things. You will also see a lot of these, especially with electricians. Okay. This one's got an ammeter built into it. What's that?
Remember keeping up that nice one for a door price. He hasn't even used it yet.
Well, now's a good time to look. Yeah. But this one doesn't have a lot of features, but what it does have is reliability. I have dropped this thing 3 stories.
oh, jeez.
There are scratches on here somewhere from where it bounced on the ground, and that's it. Again, 3 stories, 35 feet, it fell. Didn't hurt it at all. Still works. Still lights up. Still knows what it's doing. I like the probe ammeter built onto it because you just shove that around the wire and it tells you how many amps is running through that wire. And of course, this itty bitty guy here is what they call a smart meter. Big air quotes because it's not terribly smart. But one thing it does do is it auto ranges and it auto decides what you're measuring. So if you're measuring something with capacitance, it's going to tell you that's got capacitance, and we're going to measure it as a capacitor. Battery's loose or something. But it's got auto sensing. It says, oh, we're going to try measuring a bunch of different things. And it says, oh, hey, that was a conductor. But one thing this has that a lot of the other meters don't is it can actually measure capacitance and inductance, which is really useful, especially when you're talking radio stuff. So all the good tools, needle nose pliers. I'm sure we all know what those look like, but needle nose pliers. Grab things with them, keep your hands from being burnt by the soldering iron, all those fun things. Helping hands. I see more than a few of these out here. Weighted base, articulated arm, couple of alligator clips. A lot of them come with magnifying glasses. I don't like the magnifying glass. You'll know mine's missing. They're not terribly good, and they're never in the right place on these things. To be fair, I have a magnifying glass, just not on the helping hands. That part is the weighted base. Keeps it up. You can actually hold quite a bit with them. I usually keep a magnet on mine because you never know when you need a magnet handy. I keep a couple of spare alligator clips because they make great heat sinks for soldering iron. You never know when you're going to need extra heat sinking. The idea is to keep the heat at the solder joint, not in the component. Fume extractor. You can hear it running. This guy over here. It's just a fan with a filter in front of it, blowing air out the back, and it's going to pull all the solder smoke towards it.
Right, so it's good. Right here. Yeah.
Well, the nice part is the smoke gets stuck in the filter and Kurt just gets the clean air. Oh, I skipped one. Solder paste. When we're talking really small components, and I will demonstrate some of those next, solder paste. Instead of solder as a wire, like this stuff right here, we have solder as a paste in a tube. It's like runny toothpaste. And it is solder that has been milled to a fine powder and mixed with flux paste or liquid flux or a combination thereof. And you apply it like paint, like frosting. And the tip of your iron will melt it. And it turns into a nice molten pool of solder. Speaking of solder, I'm going to turn my iron off because it takes just a minute. So, solder comes in a variety of types and flavors. We have, my personal favorite, good old 6040 rosin core. I prefer a really fine solder wire for most joints because, well, it's precise. This wire is thin. This says it is 0.6 millimeter. As compared to this other stuff I also use. It's a little bit bigger. I have even bigger. The really big stuff is useful for plumbing. And that's about it. Both of these rolls are 60-40, which means 60% lead, 40% tin. Lead-free solder exists. It probably came in the kit.
Isn't that all it's supposed to sound better?
No, that is all they're supposed to use to assemble commercial electronics. There is a whole lot of politics involved in that, and the choice for absolutely lead-free solder is not necessarily a good one, especially for hobbyist use. Lead-free solder does not work as well in many situations. It requires higher temperatures, and the joints tend to be more mechanically fragile.
So if I have a choice here of lead-free rosin core, lead-free acid core,
Okay.
or something that's tin and silver,
Well, if those are your choices, well, what are you going to be soldering? Okay, for the record, your soldering iron should never have acid core anywhere near it. Nothing in this room should have acid core anywhere near them. Acid core solder is literally that. It is a dry acid encased in a tube of solder, and it is for radiators. You could use it on copper plumbing if you really needed to. I have found that a good piece of sandpaper works better than acid core solder, because acid core solder is literally there to etch the metal so that the solder sticks. Okay, acid flux solder is almost impossible to clean the residue off of, especially on circuit boards like we're going to do today. And in the long term, you will end up with a piece of broken equipment. Acid core solder is not for anything we're doing here because it will ruin your soldering iron tips as well. So you want either a rosin core or a no core with an external flux. We have flux pens. I don't know if everybody has one, but we can certainly pass them around. Flux works really good. I have a few spare rolls of rosin core fine wire that I can share around. But speaking of alloys, this stuff here is a tin silver alloy. Higher melting point. But this tin silver alloy is tough. This is the stuff we use for really high strength applications. It can actually be used for structural joining, or at least mechanical joining. I wouldn't use it to put a building together, but this stuff will actually hold. What's that?
Dentists use that.
You won't use this in your mouth, but not this particular alloy, because it's got some other things in it, and it can be a little bit
Toxic.
yeah, that's the word, a good word for it. It can be a little bit toxic in humans.
What's the flux number on solder? This says 1.8%, I think.
That sounds about right. So you don't need a heck of a lot of flux in a flux core solder.
So the rosin is the flux.
The rosin is the flux, but we will still use flux pens and all that externally.
This is rosin.
Okay,
Yes.
but
That's interesting.
but soldering irons themselves. Here is my old beast.
Oh, damn.
Right, it's got some battle scars, doesn't it?
This had battle scars before I ever saw it. My grandmother bought this soldering iron when I was just a few years old. Weller, you cannot kill this iron. This has a temperature controlled tip. Inside this tip is a little magnetic actuator, which is kind of stuck there. It is. That actuator actually moves in and out with the temperature. And the heating cartridge is down inside that too. So it goes in. It's actually held in by a magnet. I mean, it's held in. But as it heats up, that spring in there moves. And if I use this one, we'd be hearing it click constantly as it heats up and cools off. Fun times. We're not going to use that guy because it's big, it's heavy. I will use a sponge off of it though, because, well, it's useful. Everybody saw my Radio Shack iron earlier. Here's my new one. This is my Pine Cell. It's a USB-C powered smart digital iron. Kind of fun. Yeah, it's like that. But it does the job, and it does it well, considering it's has as much heating power as my big Weller or my Radio Shack iron. This has a 50-watt tip on it.
Is that temperature?
Yeah, digital temperature controlled. It's actually got a reprogrammable firmware. Yeah, it's because if we can go excess, let's go excess.
So they run really.
Yes.
Does it run Doom?
No, not enough resolution on the screen. So, other tools. Big old magnifier lenses. Because being able to see what you want to do is important. The only other thing I was going to go over really quick was component sizes. The kits we're going to be doing today, the components may look small, they are not. They look small only because you're not used to what you're seeing. Yes, they're small, but they're not real small. For example, here's a box of capacitors.
It's a huge one.
Yeah, those are medium small. There's some 1208s, there's some 604s in there. I left a really small one at home, but here's some through-hole capacitors. You know, decent sized capacitors. If you're working on, a car stereo or something, this is what you'd probably be seeing, guys like this. But I have some other capacitors in here.
Binford 6900s.
There's the numbers if anybody wants to read them.
Turn it over. What do you do?
How many do you have?
Oh, you mean that way?
Yeah. Oh, yeah.
So, how many do you have?
This, I only have the matched pair.
Um,
So those are the ones you like to see in having power.
These are the ones you bring a crowbar to check if they have power. These came out of a 40 horsepower speed control. But, we talk about components. Component size here.
huge. Come on, you keep it.
Those are all transistors. There's a couple more mounted on a heatsink. Okay. You see that guy right there?
So 23.
That guy can handle probably a couple amps. Probably 10 or 15. These guys are probably 3 or 4 each. These guys are rated for, what does that say? 98 amps for the pair. Those are all small. That is also a transistor. That is a single transistor with a monitoring circuit attached. This transistor can handle 100 amps at 1200 volts. As a friend of mine has said more than once, these things handle enough power to jumpstart a space shuttle.
Any idea what that came out?
This came out of the same motor controller as those capacitors.
Really?
Yeah, this comes as one of 3. Yeah, this will handle a lot of current. You could jumpstart an entire fleet of trucks with that thing at the same time. Oh, where's it? Ah, yes, the really small stuff. Where'd they go? Oh, yes, the diodes. Diodes are important. We use a lot of diodes. These are all diodes, even though some of them have 3 legs. Can you see those clearly? Close to clearly? Okay, all different size diodes. Anywhere from, very tiny, quarter watt and smaller diodes up to, 10, 15 amps of current continuous. And then we get up to the big guys. That is a 3-phase rectifier.
We got one of those in the both thing.
This weighs more than your Bofang, but that is a 3-phase rectifier. It can handle 400 amps of input current and converts it to DC. Not very smooth DC, but DC. For the record, this goes with those capacitors as well. But when we're talking component size, that's what we're talking about. Anywhere from very small surface mount stuff up to monsters. We're not going to be soldering on monsters with these irons. The only other real component you guys might know about, these little guys, these are all inductors, aka coils or chokes. These guys, well, they're half of a resonant circuit. I show you bigger ones, but well, we all know what a coil of wire looks like. That's the easiest one I can think of to demonstrate. I have a coil of wire. That's a big old inductor. These are small. Now, before I move on to showing how bad or good I am at this, are there any questions? Nobody? I was hoping I'd confused somebody by now.
Only me.
Well, yeah, but you're easy. All right, so we're talking about desoldering earlier. It's something that comes up a lot because anytime you're fixing a broken component, well, you got to take the bad component off the board. Here's a board, a sacrificial victim. This particular victim used to be a driver board for an uninterruptible power supply. Add a couple of balancing coils and some really big batteries. This used to handle 1600 kVA. There's a brand name on it. I'm not going to bother repeating it. People know who they are. But it's got transistors, it's got resistors, capacitors, all sorts of fun components. Basically, this thing takes AC, turns it into DC, which then get turned back into AC. What keeps your computers on long enough for the generator to start. I'm going to take a component off of here, hopefully well, and then we'll get on with making the kits. Wake up my iron because it helps to have it awake. Unfortunately for me, this particular circuit board was built right about the time they started making the change over to lead-free solder, which, by the way, led to its demise. I said before, lead-free solder is a little more brittle. Well, time and age tends to crack solder joints, especially when they're lead-free. The lead is very ductile, it's flexible, it can handle vibration better. So we're going to take this guy off right here. Can you see that? The big yellow disc there. That should be a PTC.
What is?
Oh, nope, it's an MOV, metal oxide varistor. I don't think we have any of those in the kit, but they're there. But one of the things we do to make removing lead-free solder easier is we mix in some leaded solder. So I've got my sponge for tip cleaning because, again, it always works better when your tip is clean.
What temperature are you soldering everything?
Right now, my irons should be idling about 420 degrees Fahrenheit. Nice and warm. So you will note already that by adding that solder, I changed the look of the solder joints. You notice how these are kind of dull looking. The new ones I did are nice and shiny. Well, that's just the nature of the solder itself. The tin solder tends to have a duller finish than the lead solder, at least before they age out. And even after it's aged for a while, the tin stuff, while it may stay shinier long term, it never shines. So I've melted some leaded solder into the tin free. Basically, I've created an alloy in there. It's not terribly great for anything, but it works. I've got my solder sucker. You note I compressed it, put that on there. Half of it's gone. The thing you got to watch out for is when you eject it, that the solder is all over the place.
So you're just putting the soldering iron right on, just not,
I'm putting the soldering iron on the soldering joint.
it's hard to tell.
Components on this side.
Okay, but the wires, onto like that metal conducts heat.
Oh, yeah, absolutely.
Right? Doesn't that hold the component?
It can if I leave it on for a long time.
So is that the practice that you're gonna walk up to? Or you
Yeah, we're going to be doing exactly that. We're going to be making sure that we actually heat up the joint. So I've checked. There's still got some stiction on that solder braid.
Is it on the two-layer board?
What's that?
Is it on the two-layer board?
This one is only a 2-layer board. We don't need to. Okay, solder braid. We put the solder braid on the joint. We put our soldering iron on top of it. The braid gets quite warm all the way up. It conducts heat. But the idea is that in the process of conducting heat, you'll note the solder braid is now full of solder. Solder that used to be down here.
So the idea is the little suction thing is your
The suction thing is the bulk removal. The solder braid is the fine removal. At this point, yeah, it's almost done. But now I can go ahead and I can grab the component from the back or from the front. It's going to be a little warm because all I'm trying to do now is pull it out of those joints. And by the way, dirty solder tips don't conduct heat well. And this is not the best iron for doing this, quite honestly, because my bigger irons have more heat mass. Come on, you guy. Yeah, there we go. Starting to loosen up. It's quite warm. You're not going to do this without getting your fingers warm.
Use wires.
What's that?
Wires.
Yep, tweezers, vice grips, chisels, whatever it takes.
Can soldering iron melt the boards?
Oh, you can definitely scorch these boards.
Okay, because it's so hard to tell what you're actually touching.
Okay, well, let's see here. You see these two joints here? One of these goes to a component on the other side. And that's what I'm heating up. You can see I've already pulled the component out of the other one right there. To help if I can do it so you can see it. Component was going in that hole right there. There's the leg of the component I just pulled out. These MOVs, metal oxide varistors, are actually kind of awkward to desolder, partially because they're so huge. They're meant to conduct heat well. That's part of their job. So desoldering these things is always a pain, but they're worth doing. Yep, there it is. My father taught me to desolder stuff like with using my fingers as pliers back when I was, I think, 9 or 10.
Mine did too. No, it seems.
So that is desoldering at its most basic. Again, if I was going to do a lot of it, I would definitely pick a different iron. I'm actually using this iron because it is so lightweight, because it is so small. It's fun.
What about the different tips for that pine sill? Did those conduct more?
Different tips for the pine sill might conduct more heat. The problem is they're all small.
Right.
Okay. No. Let me unplug this so I can pull it out. That's the entirety of the heating element, and I actually grabbed it at the heat break. That's relatively cool back here. I mean, I can put my hand on it even though I was just melting metal at the other end.
Okay. Yeah, but you mentioned the thermal mass.
Thermal mass, it's the actual hot part of the iron.
Okay, so if we've got say you've got a filling that's, about an 8-inch, it's 2/16. Does that have more mass than that full?
It's literally about the weight.
Okay, so you really not only want something light, but you want something thick.
You want something dense,
Yeah.
heavy.
Okay.
So That's what thermal mass is literally dense, heavy. So now that you've all watched me do bad desoldering with this iron, are there any questions?
So, would you have possibly used your helping hand there somewhere at home trying to do it?
Putting that off for a minute.
Different iron.
Sometimes, quite often when you're desoldering, it's a matter of having access to the board. Okay, I need to get to both sides of it quite often. The helping hands are not necessarily good for that. You end up clamping it in the helping hands, and then you grab the helping hands and you're moving it all over the place that way. It gets awkward, and it gets awkward quick.
It's a simple vice,
Um,
just to hold the board.
I don't have a vice.
Okay.
I have a pan device that has arms.
Yeah, I keep saying I'm gonna get one, and
then it's on this ball joint.
yeah, those things are grand. They're lovely. I've worked with them. I keep saying I'm gonna get one, and then I find other toys.
What's it called?
That's the device.
EANA.
Okay.
So we all have kits. Let's look at these kits because they come with really weak instructions, I'm sure.
It's probably in foreign language.
No, it's nothing.
4 steps.
This board is just a simple demonstrator. You spin it and lights flash. That's how you will know you've got it right. The nice part is they put some nice, simple markings on the board so we can figure this out. We have in here some very small resistors, couple of chip capacitors, couple of transistors, which are thankfully matching, so we don't have to guess which one's which. There is
The tube do that.
two high density, there are two 1 meg ohm resistors and the rest are 1 kilo ohm resistors. I'm not here to teach y'all how to read resistors, but hey,
Yeah, there we go.
Some colorblind.
Which is, that's like that. But, oh, the picture.
How do you want to approach this, Shawn? Do you want to take a component at a time?
I think we will take a component at a time.
Kind of give them a lead rather than stuffing and soldering.
Yeah, I'm gonna measure a couple here because their resistors are not the ones that were shown on the,
Yeah, so don't start putting it together until we get a feel for what's going on.
while we are waiting for the iron to heat up, we get to look at our components and figure out what we've got here. Okay, so this kit comes with 6 resistors. That's these little guys here.
So did you get that?
2 of them match each other. 4 of them are not. Basically, you got 2 varieties, 1 K resistors, 1 meg resistors. Okay. So you're going to need some good magnification or a multimeter. Anyway, gentlemen, if you look at these resistors, one of them has a green ring on it, or 2 of them have green rings. 4 of them have red rings. Those are the ones we need to know. Okay, it's going to be brown, black, green, or brown, black, red. The 2 that are probably green, you'll probably want to have somebody double check you.
Yeah.
Okay,
They go on the outside.
yep. And we do it really simple. We bend them.
They go flat or stand up?
These are flats. And the leads go through the holes and they go all the way down.
Does it matter which direction it goes in there?
No. These ones, it does not matter which direction they go
My
in.
advice, pick a direction. So
Pick one and stick to it.
all of the, if you're holding the board, there's a horizontal direction and a vertical direction. And I always put the tolerance band on the right for whatever the
I also-
horizontal direction is that I pick, and the tolerance band on the bottom. And that way all the resistors are oriented the same way.
So you don't have to flip it back and forth to read them.
You're not doing that trying to read the resistors.
Start.
It is useful. And the easiest way to do it though is just bend them, grab the leads, pull them down. These things are so small. One of the things you will learn if you do a lot of this, order of operations usually matters, but only to you. All things being equal, I prefer to install my higher resistance values first. So in this case, I'm installing the 1 mega ohm resistors first, which are the 2 on the ends. And then I will install the rest because they're all 1K after that.
So the two to match go on the
The-
ends,
the- the
R3,
pair-
the R4.
Yeah. The pair, which are 1 mega ohm each, go on the ends. And hey, you can actually see the green band there.
It does exist.
It does exist.
Can you show the other side? Like,
Certainly. I bend the leads over. Because this way, by flattening the leads out, they're not going to fall out when you're on this side soldering. Because we don't solder from the other side. As a general rule, you want these close to the board.
and that's just to conserve space in whatever container you're using it.
Well, it's to conserve space, to manage heat. Normally, when we're talking about thermal design, all of the thermal design is done assuming the component is resting on the board. So there's a view with all the resistors on.
Oh, shit.
I've got stereo microphones.
Okay. Next thing, because we're quick and easy. Capacitors, these orange things. There's only 2 of them. They're easy. There's 2 holes. Well, 2 spots for them. They go in, bend them over.
These aren't polarized, so.
Yeah, these are non-polarized devices, it's just like the resistors. They go in, they get bent over.
Yeah, these won't.
And it's okay if they bend over and touch each other. We're just not going to solder them together. That would be bad.
Do you push these all the way down as well, or leave a little space on the front?
We push them all the way down. If the camera will focus, you can see. Bob, up at the screen.
Nice.
Oh, okay, that's about it.
These go pretty quick. They're pretty easy, guys. So if you look at the resistors, or you look at these LEDs, these nice shiny clear things, the 2 wires on them are 2 different lengths.
Right.
See if it shows up here.
Yep.
Yep.
Okay. The short leg goes towards the resistors. Okay. These ones matter. The short ones go towards the resistors. The best part is it doesn't matter which order you put them in at. Everybody's going to be a little different here. And this is what she looks like
Yes.
with all the LEDs installed.
Operation that to make sure I don't solder the leg of the resistor.
Well, okay, you can find like at 45 degrees.
Okay. Last thing we're going to do before we put some solder on this
So they're obviously.
is set the transistors. Is everybody got their LEDs in?
Yes.
Yeah.
Bob?
Yeah.
Okay. So transistors. Nice part is these are both identical components, so it doesn't matter which one goes where. There's a flat side and a round side. And thankfully they marked the silk screen to match. You push it in until it really gets down to those notches that Bob was asking about earlier. And they go in till there and just fold the legs over. So you'll have 2 of these black transistors on the board.
Almost got it. You beat me up in the hall, aren't you?
I tell you, what, if people start talking leads, I'm gonna leave the room.
Anyone colorblind?
Oh, yeah.
Oh, yeah.
How's everybody doing?
Do we all have all of our things on the board?
I think so.
Transistors.
Colin?
Not the-
You all caught up?
Yep.
You looking like we got here?
Yep.
Okay. Now, you will note we have a few things left over. These 2 clips, a couple pieces of brass, and a screw.
Also the wipes.
Well, and batteries. Okay.
We haven't done this clear piece yet, though, have we?
Oh, yes, this clear piece. Where did this clear piece go? There it is. This is a switch, believe it or not. So this clear piece, we need to make sure we mount the correct way. You will note if you look at this guy that there is, well, it's got 2 legs coming off of it, and one side's, well, there's an outside and an inside basically on these things.
Make sure it fits inside the box.
Yeah, yeah.
Yeah, the leads are offset, so if the silk screening's any good, it will
Yeah.
Right,
Yes.
right.
glue you in as.
That was a loaded question.
So-
Screens, good. Those little kids, you know.
Okay, how many of us have encountered incorrect silk screening on boards?
Yeah, no, it's the leads are offset, so you can't like tilt
Yeah.
it up the silk screening.
That's a good
The
work
leads are
practice,
offset
too.
to
This kind
one
of thing,
side.
like, what would you search for?
So there's only one way to sit within the box.
Toy, solder.
I look for soldering practice kits.
Solder practice kits would be the thing I would search for.
Yeah.
That's what I searched for when I wanted to teach my
This-
daughter-in-law how to do this. I just searched for solder
This came out
practice
of,
kits,
this
and
is Amazon.
Yeah.
They had to have 100 of them on there.
yeah, I just told her to
Yeah, I have a huge list of them.
pick one, and I would order it, and then I would help her put it together.
So when you look at it, when it's on the board, there's an obvious outside and inside to it. The spring goes on the inside because the inertia sends it to the outside. So then we can flip it over and start doing the soldering. And it doesn't hurt to wrap the leads on that spring all the way around the board because otherwise it wants to flop. Okay, so we have our soldering iron. They should be on. It should be set at about 420, 425. Okay, it's good temperature for this soldering. We have our board with a whole bunch of bent over leads. Should be, component side down so that we can verify that we have everything in the right place. But more importantly, we're looking at a mess of wires. Now it's a case of pick a mess of wires, pick a joint in there, and start soldering. Hot iron on the joint at the base.
Do we need to tin the end first, or
So then are you touching the solder to the soldering iron or?
I am touching the solder to the point where it meets the joint.
Hey, Paul,
Yeah.
what's your opinion about something over here rolling in Paul?
Sean, are we supposed to? What it was it called? Setting the tip?
Okay,
Look at
Especially because
you don't necessarily have to tin your tip.
Sponge, but
Point of tinning the tip?
Wait, because it gives a better flow.
It can give a better flow. The idea is to keep the tip clean. Having it cleaned and tinned is best. Solder flux never hurts. With these solder pans, can't put too much on. The most you can make a mess, but you can't put too much on. So
So just keep soldering?
just keep soldering. You're gonna put a solder joint on every one of those.
But okay, so that needs to go.
Should we?
rolling.
The tip is probably due over the.
Just stick the pin and, just like the old.
When I did it, it just remains.
I mean, sorry, so it's
Yeah, well, this is the one, yes.
Okay.
Cool it now.
all right.
Wow, the Radio Shack soldering iron from 1960 first one. Yeah. All right, got it by my dad or something.
Get the filter out, make sure we did this.
Yeah, they had some jump products.
So, as soon as you got it soldered, it's okay to flip the wire.
Well, hold on just a minute there, Bob.
Right before it's get you to redo it. The thing you want to look at is you don't, when old solder looks kind of dull. Yeah, if it's dull, there's a chance that you didn't make
So
the
that's what you
penetration.
want to.
That's a question.
Hey, Jazz.
Hey.
A week for a second.
Yeah, you're cooking with gas.
Well, hopefully he's cooking with electricity.
Yeah.
When you say did fine, how can you tell if this, how can you tell if the solder joint is good?
It's actually looked at up.
Or it feels solid and,
Yeah, they look, so it looks good.
I mean, how much abundance of solder is supposed to be there? That's in the.
So the one in the upper left,
Yeah.
my eye was a little bit on the dry side. More solder there, I'm paying off. If I were checking this board, I'd probably trend those.
Oh my God, it's still kind of the whole.
Yeah, you know, and I like natural, like.
Sure, that's true.
Yeah, just me.
So you don't want to put the soldering iron on this wire bulb, so you want to put it.
So you want, so there's the through hole
Right,
on the board,
yeah.
and then there's the lead, and you want to make sure that you're getting both, that you want both of them on.
So you gotta.
So you gotta touch both of them,
Okay.
and having a little bit of solder on the tip of the iron makes it easier to get heat conduction from the tip to both of those pieces.
Okay.
Save.
Okay.
I think some walls are very strong. Big elements against the other ones. That's something.
You should call me name. Yeah. But you know, all of that is fixable. And Sean's going to give us a lesson in how to fix soldering, right?
All right.
Yes, Shawn is going to explain all of that.
They were followed it.
Flow solder, like machine solder.
Yeah.
You go in and make some solder. You see the solder you.
Oh, that's not
Those dull. You go hit it with a pencil. You solder the roof.
Yeah, so the bar's gonna happen is,
Yeah, cheese.
you sit there, you pick the soldering iron on, one of these, one of these. So to be so managed, it's your right to so that you can see that board, but you said want to make solid content. You said iron, you said no to that.
Don't come. Yeah. Solder everything. The solder.
Yes.
Yeah, solder.
All right, right. Yeah, going on to the brand.
Okay.
Got
Gotta find that spot.
It was like, not everything is really stayed on.
Right.
It's not like never, but. For
Right.
You just have done that one yet? Oh, yeah, the seven. That was, gotta be careful because that was jumping all over this.
Oh, Sean is drawing the essential diagrams.
Shawn is drawing the essential diagrams on his tile.
Instructions.
I believe I did. I'm pretty sure that's where I learned them. But the first kit I soldered on was a Heathkit 110 baud acoustic coupled modem.
Really?
Yeah. The first thing I ever soldered, did that with my father.
My first kid, youth kid, back in the bolt. That was like, really useful device. That made it amazing. Of course, it was the size of shoe locks.
Yeah, but they were also bulletproof.
Yes. There you go. Make progress.
Very, very reliable tools.
Okay.
So anybody wants to look up here, I can explain really quick a couple of good and bad things to look for in solder joints.
Sure.
Okay, we're viewing from the side here. You want your solder joint to look like a relatively smooth mountain from the side. Okay, we're viewing this solder joints from the side. If they're really sharp peaks,
Okay.
you don't have enough solder in
It's
there.
not like it's gonna make.
You have way too much solder in there.
Describe that with
If they look like a choked anaconda, you want the solder to actually be all the way down on the board.
So you can see the bad joint is kind of cheeky.
Yeah. Okay. What's that?
What do you call that one?
That one choked anaconda.
Oh.
Pineapples, that works too. Pineapples actually looks really good. The other thing with solder joints is when they cool off, they will change texture. They will be nice and shiny and super smooth, and then they'll cool and they'll get a little duller. It's when they get very dull that you have a problem.
Yeah.
The only problem with these little kits is they move around.
We couldn't open this one set. No. Actually, stuff like that.
No.
Oh, boy, no.
That's what robots are for.
They did what, so immediately meet on the screen.
I wouldn't want to do
Why are we looking over there?
Wow, that's good. So a useful trick for checking is to sort of rock it back and forth and let the reflection of that overhead light go across the surface. So if you can see.
I've got since I pulled on the board right now, I need to like see my workspace up. This is.
We solder the switch on?
Yes.
Okay.
The best part is when you're done soldering, you get to straighten the legs back out. Makes them easier to trim.
Yeah.
Gotcha.
Plus, that also gives you a good indication of how good your solder joint is.
What's that?
When you stand the legs back up.
Oh, if it like falls out.
Yeah. If stuff falls out, you didn't solder it right. But standing them up is going to make it much easier to trim them.
Yes.
So that's what I call reasonable. Is okay. It's on the board. Reasonable. At this point, we set our irons aside. We don't bother turning them off yet because odds are we'll have to pick them back up. Okay, when trimming leads. Okay, this takes a little bit of practice. I like to hold the board and put my finger on the lead I'm trimming. The other option is I also like to put a magnet on the back of my cutter. Okay, I put a magnet on my cutter because all of these leads are nickel coated steel. Okay. The magnet will hold the leads that I'm trimming. But for demonstration purposes, I have a board, 2 fingers holding onto it, another finger on the lead I'm going to trim. Okay. Close to the board, and the lead just falls out. Okay. Finger on top of the lead, and you can trim with the edge cutters. The idea is you know where that lead is falling. Okay. We're on a carpeted floor. And if you think these won't get lost in that carpet instantly, I have a foot injury just to talk to you about. Because you will note when you touch these are sharp. The last thing you want to do is find these in your home with your bare feet or stocking feet, because they will get into your socks and they're just uncomfortable to step on. And the idea is we are aiming for close to the circuit board. You don't want to cut into the circuit board, and you don't want to cut in deep into your solder joint, but it's okay to trim off the very top of the solder joint. Yeah, but we really don't want to trim off your fingers. Would much rather you cut 2 or 3 times than to have you cut into your fingers. I will say, though, that most of the time, these edge cutters are really good at fingernails if you need to trim your nails. You are going to have really sharp edges, though, and yeah.
Yeah, that's good. I'm looking at that. I like that. I might not have done that. I have magnets on all sorts of stuff. I don't even know.
Isn't that just the neatest thing?
Yes.
Hey, Tom,
Yo.
how you doing?
Good.
Did you remember to stand him up before you started trimming?
Roger.
Because long term, this is what we're looking for on the screen here. This is where we're going. Okay, next thing, once we're all trimmed up, is putting the battery holders on. Somebody jumping ahead here. You know what? That's okay. The idea is these take a little bit of extra work to solder just because they're bigger.
And all that gas is pretty.
Yes. Yes. All the gas. Yeah, awesome.
Okay,
Let's see what else.
so the battery clips are springs a little bit.
Yeah.
They get soldered on stacks.
What's that? They get soldered. It's just, they're awkward to install. But and this is also why we put them on last. But it's also why we left our soldering irons on.
Yeah, take a little more heat.
It's going to take a little bit more heat because they're so much larger. So you can put the soldering iron on that joint and you can wait for the battery clips. Go ahead and put both battery clips on.
You see, you can't overheat the clip, where it's very hard.
Yeah.
The clip, nothing bad happens.
By the way, this material the circuit board is made from is actually a resin impregnated fiberglass called FR4. FR is fire resistant type 4.
Didn't you hear fire proof?
You are correct, sir. You did not.
What was sorry I would say.
Yeah. Is there preferences to which way the battery goes in? Whether through the diodes or the
Well, the battery clip goes on, and then we'll worry about the batteries because the batteries go in a specific way.
Well, I know that, but I mean, as far as getting the battery going.
No,
You're asking which way the mouth of the battery holder goes?
Yeah.
no.
Yeah,
I would pick the way that most likely would make getting the battery into the holder less of a pain in the ass.
yeah.
So maybe the
Yeah, it's kind of where I.
I think it's easier than somebody thought, so, because this side has the switch.
Yeah, that's what I would say.
So it's still
I don't think those are. Yeah, I'm doing it too. Yep.
If you have a screw and two brass pieces,
Yeah.
small brass piece, screw, make it look like that. Colin, did you need to clean yours?
No.
Okay.
Also, I'm pretty happy with the black and white.
Yeah, it's not a complicated kit. Go ahead and thread your small brass piece through the screw.
Did you have just a little bit, is it loose?
No, mine's tight.
Okay.
Mine is tight.
Away from the board or positive?
Positive towards. Nope, sorry. Wait. Sorry. Let me read what I'm looking at here.
Wait, sure.
These are standard 2032s. We're going to go negative down. We'll get there in just a moment. We got to put the spinner part on first.
Oh, yeah, you got to do the mechanical.
Well, see, there you go, jumping ahead again.
Watch Mel.
Yeah, he's just a troublemaker. Okay, so little screw through the small piece. Screw it tight. Screw goes in from the bottom.
It spins.
And we thread the big long piece on. So we're making a top.
In the breakfast pod.
You will notice, looking at the battery, you have a side that is marked with lettering and another side that is just textured.
Right.
The textured side goes down into the holder
Toward the board.
towards the board.
And if you're holding it over your head, it still goes through the bridge. You can go that songs.
This is one similar technique with boarding, like the port starboard.
Yeah, well, you know, it's.
To the.
Hey,
Stand.
It's right.
Look at that.
Mel's got a light.
Oh, stay with me. Look at that.
hey.
Yeah, mine doesn't want to write.
Wondered to get a better thing.
No lights and no rays.
Mine doesn't want to bounce.
Hey, this is awesome.
Well, we figured it'd be fun to solder something out. Take something.
I did soldering at university and now it's called
Congratulations. You all know how to solder, at least basically. They may not be pretty solder joints, but nobody expects you to do perfect, pretty solder joints your first time.
Really balanced well.
I don't know. I have expectations for myself.
You know, I have expectations for myself too, but I've been doing this a long time.
Yes, you have.
Now, do you differ with me on this point? When you're done soldering, you leave the solder on the tip, don't clean it off? That's why.
I tend to clean my tip, but I also don't scrape it clean.
Yeah.
I will wipe my tip off and turn the iron.
Yeah.
Anything that's left, that's fine. But the problem is when you leave the solder, when you leave big blobs on the tip, they're going to oxidize heavily
Yeah.
when you turn that iron back on.
Give it a quick way.
I give it a quick wipe. There's a little bit of solder left on there, but no big blobs. When you leave too much solder on and it oxidizes very heavily when you reheat the iron, it takes a while to clean it and get it working again.
Yeah, you like that, Mayor?
And I'm not a fan of cleaning too terribly much before I get to going. I'd rather clean at the end. And then I forget to clean at the end. Okay, so I will unplug my iron
Let's get everything cleaned up.
and then start the cleanup.